In this video, we talk about combinations of functions. That is how we can use addition, multiplication, subtraction, division to create new functions out of old functions. So we'll look at this in different contexts with functions given as equations, as graphs, and as tables. So first we have f of x is 2x minus 3, g of x is x squared plus 2x. Can we find f plus g of negative 3? And the idea is we'll take f of negative 3 plus g of negative 3. So f of negative 3 means we're going to go 2 times negative 3 is negative 6, minus 3 is negative 9, and g of negative 3 is negative 3 squared is positive 9, and 2 times negative 3 is negative 6, and 9 minus 6 will be 3, and so we will get negative 6. For f times g of negative 3, that's how we write it in the green, so that is f of negative 3 times g of negative 3, and we said f of negative 3 was negative 9 from earlier, and we said g of negative 3 was positive 3 from earlier, and so that will be a negative 27. For f minus g of negative 3, we'll take f of negative 3 minus g of negative 3. And so we said f of negative 3 was the negative 9, and g of negative 3 was the 3. So that will end up being a negative 12. And changing the order, we're going to get g of negative 3 minus f of negative 3. And g of negative 3 we said was 3, and f of negative 3 was negative 9, so that will be a positive 12. Now, for the division ones, we have to be a little bit alert because we just want to make sure we don't end up dividing by something that is negative. So here we're okay because f of negative 3 is negative 9, and g of negative 3 is 3, so we'll just get a negative 3. Now the next one, we've got f of negative 2 over g of negative 2, and this might be a problem. Let's see, f of negative 2, we're going to go 2 times negative 2 minus 3. That's negative 4 minus 3, so that's going to be a negative 7. I'm going to erase my work there and say that's going to be a negative 7. But g of negative 2 is going to be negative 2 squared plus 2 times negative 2. That's going to be 4 minus 4 is 0. That is a problem, so that actually is not defined because we can't divide by 0. Okay, with that in mind then, we can create, so here we evaluated these functions at numbers. Now we're going to, and I'm going to rewrite here, f of x, remember, was the 2x minus 3, and g of x was the x squared, I think, plus 2x, so I don't have to keep scrolling up and down. So what we're going to do for creating this new function, f plus g of x, is what you would kind of expect, I think. We're just going to add those together. So that's going to be a 2x minus 3 plus an x squared plus 2x. We'll combine what we can combine, so that will become a 4x minus 3. So we create a new function out of two old functions. And for f minus g, we're going to take f of x minus g of x. We mostly have to be careful that we distribute that negative sign. So that's going to be a 2x minus 3 minus all of g of x, which is our x squared plus 2x. So that is going to be 2x minus 3 minus x squared minus 2x. So those will cancel, and we'll get a negative x squared minus 3 is our new function. F times g is going to be our f of x, which we said was the 2x minus 3, times our g of x, which is x squared plus 2x. Some of you like to do this with a box. However you want to do it is okay. I'm going to say that's going to be a 2x cubed, and that will be a plus 4x squared, and then a minus 3x squared, and a minus 6x. So combining the like terms is going to give us this for our fg of x, our new function, the product of those two old ones. Now, when you do a quotient, so we're going to take f of x divided by g of x, we have to, as part of this, we have to write what our new restricted domain is if that comes up. So in this case, because we now have the g of x in the denominator, and you can see that that factors into x times x plus 2, we can't have that be equal to 0. So I'm going to say our new denominator is that x cannot be 0 or negative 2. So that becomes part of our function, is its new restricted domain. Similarly, for our g of x over f of x, we're going to get our x squared plus 2x over 2x minus 3. And here we can't have that denominator being 0, so we say that x cannot be 3/2. So that is our new restricted domain. That's our new function with its domain. Okay, now same idea here, except we move to evaluating the functions graphically. So f plus g of 1 is f of 1 plus g of 1. F of 1 is we go to the green f function. When x is 1, it looks like f is 0. And at 1, it looks like the blue g function is positive 1. And so we're going to say that f plus g of 1 is equal to 1. And f minus g of 1 is going to be f of 1 minus g of 1. And we said f of 1 was 0. And we said g of 1 was 1. And so that is going to be a negative 1. Now it gets a little tricky on the graphing part here. Let's see if, I don't know if I can do this on a separate graph or it'd be easier on the same graph. Let's see. I'm going to imagine now that for f plus g of x, I'm going to go point by point. So f of negative 2 is 0, g of negative 2 is 1. When we add those together, I don't like the way I put that axis. I'm going to use the grids. Let me try that over again. So let's go with there. Okay. So when we go to negative 2, then we're going to have 0 plus 1 is 1. And when we go to positive 1, negative 1 rather, we're going to get 0 plus, looks like that's about 1.5. So I'm going to go right there. At 0, we're going to get 1 plus 2 is 3. So it looks like I'm going to have to go a little higher up. So we're going to be up there at 3. And so far, we're going to connect those with straight lines. At positive 1, it looks like we have 0 plus 1, which is 1. And at 2, it looks like we have negative 1 plus negative 2, which is going to be a negative 3. So I think we'll be all the way down to there. So this is going to be our f plus g function. So that's y equals f plus g of x. And on the subtraction, got to make sure we do the f one first. So f of negative 2 is 0 minus 1 is going to be a negative 1. F of negative 1 is, let's see, f is the green one, so that's going to be about 1.5 minus 0 is going to be about 1.5. So I'm going to say, I'm going to share a point right there. And at 2, we're going to have, at 0 rather, we're going to have 2 minus 1 is 1. So far our curve is looking something like that. At 1, we have the green 0 minus the blue 1 is a negative 1. And at 2, we have the green negative 1 minus the blue negative 2 is going to be a positive 1. So we're going to be back up to there. Okay, there is our f minus g of x. Okay, let's look at our table. So here we have our table, is, and we can see for selected values, we have the values of f and the values of g. So f, and this is now composition, so f of g of 3. So g of 3 means we're going to plug 3 into g, and that looks like it's going to be 1. We take 1 and plug it into x, and that looks like it's a positive 3. For g of f of 4, we're going to plug 4 into the f function, which is 2, then take the 2 and plug it into the g function, and that looks like it's 3 as well. And for f of 1, first we're going to plug 1 into f, that looks like 3. Then we're going to plug 3 into f, and that looks like 4. And doing g of 2, so put 2 into g, we get 3. Then put 3 into g, and we get 1. All right, I think that's the end of this one. Okay, very good. So we're creating new functions using addition, subtraction, multiplication, and division. Remember, you have to restrict the domain on the division functions if needed.